Okay, great. In the next about 15 minutes, I'm going to discuss linking surface energy budget of heat islands and the dynamics of the overlaying planetary boundary. So this study based on three realistic cities, so a little bit different. This work was done with Dominik, Richard David, Igor, Dominique, and YONGLING. Urban warming as a confluence of climate change and urban heat island effects is getting severe at a global scale. We recently quantified the global warming, the warming effect at the global scale. From the 2019 quantification, you see the majority of the cities, particularly those one in Asia, South America, North America, and some in European countries, are getting urban warming at different levels. For some cities, the surface heat island intensity can be up to 10 degrees. To be specific, roughly 5,000 cities out of 6,000 cities we qualified are getting warming at very, very severe levels. Actually, when we were doing this quantification, research question really bothered me. That is how to identify, how to characterize warming areas. That depends on, that eventually decides what is the intensity or surface heat intensity you will get. Traditionally, we have those land use or information land type based approach. So decide based on the built up area, you can characterize the temperature in cities and characterize the temperature in rural areas, and then you can find them. Right? So we thought, are there any alternatives to those conventional approach? And also another question, how about the intra-city disparities? For a city, for example, at the level of Sydney, we do expect to see very severe intra-city disparities, right? And also, we would like to look for alternatives to facilitate urban climate analytics, particularly at a global scale. So we propose the classroom-based approach, and today I'm going to illustrate the concept and to explain how to implement the approach. And also, we will show some brief or preliminary applications using the classroom-based approach in surface heat balance analysis. And also, at the end, I'll give some concluding thoughts. This classroom-centric understanding was somehow inspired by the phenomenon we call heat dome. Yesterday, our keynote speaker and also some other talks already touched this point. So here, the first image showing the planetary boundary layer height for a particular time at the nighttime 1 a.m. for Paris. And here, the planetary boundary layer height was determined using the threshold of the Richard number at the point 0.25. And on the right-hand side, you have the 2-meter air temperature for the same time instant. From these two time instants, you see quite nice spatial correlation. Actually, we not only observed this spatial correlation for this particular time instant, we observed the correlation for most of the time instant during the nighttime. This is quite straightforward, actually, because we know urban heat island effects is more pronounced during nighttime, right? So then, what we do is quite straightforward. We pair the 2-meter air temperature with the planetary boundary layer height. And then we do that for nighttime from 1 a.m. to 6 a.m. We do that for 3 consecutive days. That ends up 18 new time data sets. And then we perform Gaussian mixture model based on clustering analysis. That gives us 18 clustering outcomes. In the last step, we apply a threshold of appearance. Basically, count how many times that particular cell can be counted as a cluster of rural area or urban area. So by doing that, we can determine for city side, we can determine whether the particular cell should be counted as rural or urban cluster. So that's the approach, quite straightforward. And then here I'll give a little bit illustration to the Gaussian mixture model clustering approach. Here, as I said, we perform the clustering using the newly established data set, planetary boundary layer height, and the T2. So here we see those two clear peaks. So here that's the component 1, that's component 2. In the language of urban heat island effects, that can be characterized as a urban or rural cluster. As I said, the second question was how to study intracity disparities. Here we do have a signal C3, but here in this data set, C3 is not that distinct. But this method definitely gives us the capability to study intracity disparities. That's why we are happy with this approach. So the first two images, you already see them. That's the planetary boundary height. That's the T2. In the last one, you see That's the clustering outcome. Here you see two components, component 1 and component 2. As I said, the language of urban halo effects, here component 1 can be recognized at the urban area. By knowing these urban and rural clusters, we apply the same approach to Montreal and Zurich for 2 different years. So we are quite happy with the clustering approach. We characterize urban areas or warming areas nicely, but for Zurich, we do see a little bit exception. Somewhere along the lake, we see a little bit kind of misalignment. This was due to high wind speed. We can come to this point later, because for now, the new data set only combines planetary boundary height and the surface air temperature. We have not included the wind speed. Definitely, there is a potential there to improve wind speed and then to get a better prediction of the warming area. Now we have the clusters, urban cluster and a rural cluster. We can do a lot of analysis in a very fast and efficient way. Here, for example, I'll give you the T2 and the planetary boundary layer height for these 3 cities. It's very clear to see for all of the 3 cities, you have very distinct temperature difference for nighttime. I think everyone knows that. For nighttime, we see very severe urban hair effects. And for the planetary boundary layer, on the other hand, we see the most distinct difference happening during daytime. The difference can be up to a few hundred meters. So now we do the analysis for the T2 and the planetary boundary layer hysteresis group. Here I would like to explain a little bit. We do 3 days average for time window before heat wave, and then we do another 3 days for the heat wave period, and after that we do another 3 days after the heat wave. So we see a very nice this kind of expanding of this hysteresis group. Basically, that's suggesting simultaneous kind of deepening of the planetary boundary height as well as the intensification of the air temperature. If we would do the same thing for the 3 cities, luckily we see very nice, consistent observations. So that suggests the dynamics actually is the same for these 3 cities we are studying. We believe that related to the surface heat flux, because imagine you have more heat from the surface, the planetary boundary layer gets thicker. So now we look at the heat flux. If we look at the heat flux, that's the all-wave incoming radiation. In most of our models, we assume the incoming radiation remains the same for heat days or normal weeks. Here we don't see too much difference for the rural cluster and urban cluster. And also for the 3 time windows, I would say the incoming radiation remains the same. That's what we have in most of our climate models. And then if we look at the sensible heat flux, we start to see a little bit kind of disparity between rural and urban cluster. For urban cluster, we see a little bit broader distribution. Then we move on to latent heat flux and ground heat flux. Actually, we see the most distinct difference that lies in the storage heat flux. That's our ground surface. Actually, here doesn't tell the full story. So we wanted to kind of integration of the storage heat flux. We do that for 3 days. That's the period before heat wave. That's 3 days. You see very nice sinusoidal profile of the storage heat flux. And somehow the system, the rural system and urban system, can kind of reset to the reference or kind of a net zero value. And then we do that for another 3 days during the heat wave. What do we got? We got a very slightly gentle accumulation of the storage heat flux. But for the urban cluster, you see very dramatic kind of accumulation of storage heat flux. How about the rest of the days after the heat wave? What do we got? We got sort of this kind of restoration process. So we apply the same approach to the rest of the cities. Nicely again, we see very nice kind of we call refueling and the restoration mode of heat, kind of a historic flux. So that's what we got. As the last step, we also tried the model using to look at the historic kind of a pattern. This is important because, as I said, in most of our climate models, we assume that all-wave incoming radiation remains the same. If you know the historic pattern, you should be able to know the thermal kind of dynamics near the surface, you should be able to predict the air temperature by knowing the convective heat transfer. So that's why we are studying the historic kind of dynamics of the storage heat flux. So, concluding remarks, the clustering approach demonstrates a new perspective to study the heat flux and the dynamics of the planetary boundary layer. And second, multidimensional clustering. Here, by saying multidimensional clustering, meaning the strong wind and moisture can be taken into account to better refine the framework. And also, the intricity can be studied. As I said, if you are using 3-component or 4-component clustering approach, you can study more kind of spatial disparities. And really, a final note, we recently studied heat wave and urban heat in Sydney, because you are all in Sydney. I hope you are interested in this paper. If you are interested, you can scan the code. So that's all. I'm happy to take questions.
Thank you very much. Very interesting talk with a lot of information, a lot of stuff in this talk. Anybody has some questions, please? You have about 3 minutes left.
Matthias, I have one.
Oh,
yeah. I was looking at.
I don't have eyes in my back.
This is interesting because 2012 that Paris paper we actually nocturnal boundary height and temperature correlated pretty strong correlation. We saw that we are doing here right now. What is actually missing, I believe, I could be wrong, is that the nighttime boundary layer is pretty much atypical than the daytime boundary layer because the mechanical mixing is actually main generator of the turbulence at the high wind speed, right? And so I would say that if you can make the cluster analysis with respect to wind speed dependency, that will give you another dimension. Then you can rule out almost everything really the one-dimensional boundary layer height on the nocturnal boundary. Because if you're stratified in the rural areas, not necessarily in the urban areas, then you are actually not comparing apple and orange, right? You see the point? So I would say wind speed dependency, if you can find out in the cluster, is there any way that you can do?
Definitely, I agree with you. Wind speed plays quite, I would say, very important role. Here we choose to do the clustering based on heat wave period. That's because during heat wave normally you get very low wind speed, right? But if we want to do this clustering using for average days, definitely we need to take wind speed into account. But I don't see any problem to apply the same approach by taking wind speed into account.
So far, all the results are based on the simulation, correct?
Yeah, for now it's for the training simulation. Yeah, but I think the approach should be applied to measurements because for now we have people measuring, for example, the boundary layer dynamics, and some people measuring surface heat fluxes. For measurement data, I would say the framework should apply as well.
Thank you. Just one last question here, Natalie.
So did you try the clustering on sensible heat flux instead of 2 meter temperature? Because, I would say sensible heat flux is more of a driving mechanism of the growth of the boundary layer, and 2 meter temperature is influenced by the growth of the boundary layer.
Yeah, I didn't try, but I would say if we apply sensible heat flux with the planetary boundary layer and into the clustering, I would expect to have quite similar clustering results. Because as you said, sensible flux is more or less linked to air temperature. Yeah, I would expect to see quite similar clustering outcome.
Okay, thank you very much. Thanks again. So the next